Order, degree, and linearity of a differential equation. This is done by class CP1401, group moving house. So what is order? Let's start by the definition of order. It is the number of the highest derivative in a differential equation. A differential equation of order 1 is called first order, order 2, second order, and etc. So in example 1, 3x 2 double prime 2 minus y square y prime equals to 0. The y double prime is in the second order and the y prime is in the first order. In this equation, let's take the highest order, and that is the second order. So let's cancel out the first order and choose the second order. Example 2. X d2y over dx2 plus 3y square equals to 6x minus 8. The dy dx here is in the third order. So therefore, this equation is in the third order differential equation.
Let's move on to degree. Degree is defined as the power of the highest order derivative in a differential equation. So how do we identify the degree of a differential equation? Step 1, we should first find the highest order. Step 2, see the power. In example 1, since the highest order of the differential equation is y prime prime, we do not look at y prime even though the power is 3. This is an example of second order DE in second degree. For example 2, repeat step 1 and 2, and we will be able to know that this is a third order DE in first degree.
Okay, so next up, we'll be talking about linearity. The distinction between linear and nonlinear is pretty important when it comes to algebraic equations, and the same thing goes for differential equations. Therefore, I will explain to you what a linear differential equation is, giving some examples of linear differential equations, and I'll do it by analogy with algebraic equations. So, let us recall what linearity is. It is an equation of the first degree only in respect to the dependent variable and their derivatives. What are the different forms of nonlinear differential equations? Firstly, it can occur as product, whereby the dependent variable is multiplied by its derivatives. Secondly, it can occur as a nonlinear function. This includes when the equation has a function in terms of its dependent variable. Lastly, it can occur where the dependent variable and its derivatives is raised to power, whereby the dependent variable and or its derivatives is of power that is more than 1. So first, let us understand and recall what a linear equation looks like in algebra. It looks like a combination with constant coefficients of some number of unknown variables. From this equation, we can see that a, b, and c are some given constants, and y1 and y2 are some unknown variables. To solve the equation, I need to find the values of y1 and y2. A linear differential equation looks very similar. It will be a combination of some unknown function y and its derivatives y prime with known functions of its independent variable x, where this is a first order linear differential equation. Now, let me give you some examples of some non-linear algebraic equations, and then we will move on to non-linear differential equations. So some of these equations include y1 times y2 equals to 1, where it is a hyperbola. And second equation is y1 squared plus y2 equals to 0, where it gives a parabola. The third equation gives square root of y1 equals to sine y2. None of these equations have a form of a linear algebraic equation. So we have mentioned that some non-linear algebraic equations can exist as a product raised to power and as a non-linear function. Let's look at some of the non-linear differential equations. So first, let us look at the second derivative of y and square it, which equals to y times x. Or how about y prime times y equals to negative x? Or this one, y prime equals to sine y. With that, we end our lesson. Thank you.